Greetings, welcoming you all to the today's session on fuel cells. Fuel cells which is coming under the renewable energy sources. This fuel cells mainly we are focusing, the future generation is mainly focusing on fuel cells. The reason is these are the cells which are not causing any impact to the environment, that makes its use are widely used all over the world, and this is an evolving technology. This technology it's going to rule the world. Let us see how this fuel cells are working on and how this working functionality can be improvised in the day to day life. As you see in the fuel cells, in this fuel cells the main requirement for the fuel is hydrogen. So, based on this hydrogen gas alone, this energy can be functioning on. If you see this functioning of this fuel cells are electrochemical devices that converts electrical energy from a fuel cell into an electricity through reaction with oxygen or another oxidizing agent. In fuel cells, this would be the structure of the fuel cell. If you see the fuel cell, it has its own anode, cathode and then electrolyte. This fuel cell is doing the work of converting chemical energy into an electrical energy. We all know about the batteries. So, batteries do the work of converting chemical energy to the electrical energy, but the electrolytes what we are using inside gets varied. In fuel cells, this anode, cathode and electrolytes are mainly depending on the two major sources. One is the hydrogen, another one is the oxygen, and the reaction between the hydrogen and oxygen, it makes the impact and it can constitute the flow of electrons. Obviously, this flow of electrons constitute the flow of electricity. If you say its structure, there would be an anode, here there would be an electrode and there is another electrode. We are having an anode and cathode. Within this anode and cathode, we are having an ion exchange membranes are available. What is the need of this ion exchange membrane? We shall see it in later point of time. So, there will be requirement for anode, cathode as well as the ion exchange membrane. In this functioning of this fuel cell, we are giving hydrogen as an input. So, this hydrogen has a 2 hydrogen atom as an input. When this hydrogen ions get into this anode, what would happen is this anode and then ion exchange membrane makes the separation of protons along with the electrons. That means, it can categorize the hydrogen ions into split out the protons and electrons. This protons has the ability to get into the ion exchange membrane. There will be a fine membranes are available within this anode and electrode. In this ion, the possible protons can be get into this ion and the remaining electrons can find an alternating path. When these ions make an alternating path over here, this constitutes the flow of electrons, and the flow of electrons obviously leads to the flow of electricity. So, there will be a major requirement of ion exchange, ion membrane and then anode, cathode. This does the work of splitting on protons along with the electrons, and this electrons makes a movement in an alternative path, and when this make an impact over here to produce a closed path, in the other end oxygen has also been given as input. So, what this oxygen will do is this oxygen further improves the flow of electrons, and then this oxygen ions can combine with the proton ions that comes inside your ion exchange membrane. When this proton ion can mix it up along with your oxygen ions, what would happen is these two combinations leads to the creation of water, that means H2O. When the combination of hydrogen and that means the hydrogen proton ion along with the oxygen gets happen on, it constitutes the byproduct as an water, that means H2O. And if you see this functioning of this fuel cell, it mainly requires that functioning of this membrane. This membrane plays an important role, and that constitutes the flow of electricity, and this is what would be the functionality. So, major requirements are hydrogen, oxygen, and what we are getting the output as then electricity as well as the byproduct of water, and this is this functionality. And the choosing of electrodes, anode, cathode and then ion exchange membrane plays the important role in the selection of fuel cells, because this fuel cell has the application in multiple domains, and in each domain the utilization gets varied, that means the functionality gets varied. If it is so, this electrodes and then ion exchange membranes makes its variation. That means if I want to utilize it for some special applications, in special application and all, the concentration given to the fuel cell should be very abundant. At that case, the membranes used within the fuel cells and all are very costly, and it is more durability too. That means longer period of time we can utilize that fuel cell. So and another advantage with the fuel cell is as this is functioning mainly on with the hydrogen, it causes no impact to the environment, and that's make it special. In future technologies and all, we can definitely see that this fuel cell is going to rule the entire world. And this would be the another diagram representing the same functionality. As I told you, hydrogen has been given as input, and then this ion exchange membrane can segregate your protons along with the electrons, and this protons get into your electrolyte, and then the remaining electrons can make a movement that constitutes the flow of electricity, and this proton, when it mixed up with the oxygen and the other end, it constitutes the byproduct as an water. And this would be the functionality of fuel cells, how it is working on, as we discussed already. So here we have the fuel cells. Main requirements are anode reaction, electrolyte function, and then cathode reaction. The functionality we discussed it elaborately already. And what would be the difference? Fuel cells, many types of fuel cells are available in the market. What makes the difference? Let us see. Types of fuel cells. The fuel cells are classified based on the electrolyte what we are using on. We have discussed in that operation, that means anode, cathode, in between that we are having an electrolyte. In this electrolyte that makes the difference, because the one reason the hesitation of using the fuel cell right now is the cost wise. If you see the proton exchange membrane and then hydrogen, they are all very limited sources, and when you are start utilizing out that the cost is drastically increased as on date. But over the period of time, if you start utilizing that, it can comes down. But as on date, why we are many of them are hesitated to go on to the fuel cell is the cost wise. When you see this utilization of fuel cell along with the traditional use of thermal power sources, this cost will comes around nearly 10 times more than that normal utilization as on date, and the difference makes it happened because of the utilization of ion exchange membrane. There are multiple membranes are available as on date. The main membrane we are utilizing is the proton exchange membrane fuel cell. Proton exchange membrane fuel cell, as the name indicates that this fuel cell has a proton, and this membrane helps you to make the movement of this proton exchange membrane fuel cell. And as we know that fuel cells are entirely depending on the hydrogen, uses hydrogen as a fuel and oxygen from the air, and then operates at low temperatures. The main reason for utilizing the proton exchange membrane is for all the domestic applications, and all for industrial applications, that is under the normal temperature, this would be the suitable membrane, because its operating range is limited to 50 to 100 degrees Celsius. In the normal utilization, that means normal industries or domestic utilization, the temperature will never go more than that. So the proton exchange membrane is the feasible one. And the another advantage is proton exchange membrane is available very limited, that means available abundantly, and the cost wise also, if you see the comparatively another type of fuel cells, this would be very reasonable cost. So the application as on date is commercial, common in vehicles and then portable power applications. We all know as on date the fuel cells vehicles are starts coming onto the market. In all those market and all, mostly they are mainly using the proton exchange membrane because of its availability, as well as the trust on with the proton exchange membrane is very high. And then it comes the next one, solid oxide fuel cells. The membrane what we are using within the anode and cathode, that would be another one, solid oxide fuel cell. Here so solid electrolyte, solid ceramic electrolyte can be used as an ion exchange membrane, and the operating temperature gets varied. Earlier one was 50 to 100 degrees Celsius, this one can comes around nearly 500 to 1000 degrees Celsius. The main applications may be limited to the steel industries or iron industries, where we need to have the molten state of the iron cores. So in those scenarios, this fuel cells fuel cell can be mainly using on. And then the alkaline type fuel cells. So alkaline has done a very important role in the spatial applications. In spatial applications and all, we know that the utilization should be in the larger time period. For to satisfy their requirement, this alkaline has done a huge impact. often we can say it as an potassium hydroxide, and then high efficiency but sensitive to CO2 and all, that would be the only limitation of using the alkaline type fuel cell used in spatial applications. So, in many spatial applications and especially the NASA's Apollo missions and all, this alkaline type fuel cells are start utilizing it on. And then the next one is then phosphoric acid fuel cells. This utilization is less when compared to that proton exchange membrane, but it can be also as used as an alternative. Uses liquid phosphoric acid as an electrolyte. Operating range is around limited to 150 to 200 Celsius. If by